Okay, so in this video, I'd like to go over step functions and their Laplace transforms. So step functions represent piecewise functions, and we'll start with number 18 in the homework. We're given this piecewise function, and we're asked to find the step function and express it as a Laplace transform. It sounds more difficult than it actually is, but the procedure is to take this value, the function, so in this case 0, and multiply it or distribute it to u t minus this interval, end of the interval, so 0, minus u t minus this end of the interval, so 3. And then you just repeat. So plus 4 distributed to u t minus 3 minus u t minus 6 plus 2 u t minus 6 minus u t minus 7 plus 1 u t minus 7. Okay. And since there's no end of this interval, it goes on forever, we don't have to add anything. Just kind of ends there. So that's it. That's the step function, but we can simplify. This is 0, so this turns to just 0. This is, we can distribute that 4. And don't worry too much about that u. It just represents that it's a step function. It's kind of how we identify them. Is when you see that u, you know it's a step function. So anyways, I distributed that 4, and I'm going to do the same for the 2. T minus 6 minus 2u t minus 7. And then we're left with plus u t minus 7. Okay, so now what? Well, we can combine like terms. Even though these are step functions, we still have a negative 4u t minus 6 plus a 2u t minus 6. So we can add those together. So we have 4u t minus 3 minus 2u t minus 6 and minus u t minus 7. Okay. So now what? Well, we have to use this formula. This is the formula. The Laplace transform of a step function is equal to e to the negative s tau times g to the function of t plus tau. Well, that sounds a little bit more hard than it actually is. But basically it's saying is you take this term, t minus 3, make that negative 3 a positive 3, and plug it in for any t you see here. And then you take the Laplace transform of that. We'll see it in the next example, but in this case there is no t. So the Laplace transform of a coefficient is 1 over s, or in this case 4 over s, because we have a coefficient of 4. So it is 4 over s times e to the negative s tau. Tau is just 3. So e to the negative 3s. And you repeat for all of them. So 2 over s e to the negative 6s minus 1 over s e to the negative 7s. And that is the Laplace transform of this step function. So not too bad. I would like to do one more, and it's the same as number 19. 19's a little bit more difficult. Not as long, but more difficult because it involves a little bit more of a complicated function. So let me just erase this and keep our formula. Okay, so in number 19, we are given a graph. So we're given this graph, and from 0 to pi over 6, so this is pi over 6, we have the function 0. And from pi over 6 and beyond, we have sine function, and this is sine 3t. Ooh, ran out of room there, but this is sine 3t. So we can represent this by a step function. And I'm going to use a different notation than I did last time, and we're going to convert it into the notation that we used in the last one. So this notation basically is you take your function, so in this case it's 0, and it's a pi symbol from this end of the interval, 0, to this end of the interval, pi over 6. And then you add it to this function. So this is sine 3t, another pi symbol, from this end of the interval, pi over 6, to this end of the integral, which is just infinity. And this you can just convert into a unit step function. In this case, it's not too bad because we have a 0. So it is sine 3t. And I only show you this notation because the chapter uses both, kinda. So it's a good idea to know both. So sine 3t distributed to u, this end of the integral, t minus pi over 6, minus u. Oh, actually we don't need any more because this goes to infinity. So that's it. So we're left with sine 3t u t minus pi over 6. Okay, well we need to take the Laplace transform. So this is our step function for this piecewise function. We need to take the Laplace transform of this. And to do the Laplace transform of this, we have to plug it into this formula. So the Laplace transform of a unit step function times a function, in this case this is g at t, we have to take e to the negative s tau. E to the negative s, tau is just pi over 6. So I'm going to write that s over on this side. So we have e to the, let's just rewrite it entirely here. E to the negative pi over 6s multiplied by the Laplace transform of g of t plus tau. So it's the Laplace transform of sine 3t, well, sine 3, and then for t, you put t plus pi over 6. Or, what am I doing here? Oh, gotcha. Okay. So now what we need to do, sorry about that, I just had to think it over. We have to distribute this 3, so we get the Laplace transform. So e to the negative pi over 6s times the Laplace transform of sine 3t plus pi over 2. Well, sine 3t plus pi over 2 is really just cosine of 3t, because if you move a sine function pi over 2 to the left, it becomes a cosine function. So we'll be left with e to the negative pi over 6 s Laplace transform of cosine 3t. And we know this to be s over s squared plus 9. So the final answer will be e to the negative pi over 6 s over, well, multiplied by s because it's cosine, s squared plus 9. So to recap, we were given a piecewise function, we converted it to a step function, and then we used this formula to find the Laplace transform. And to write this formula a little more clear, it's the Laplace transform of a step function multiplied by a function is equal to e to the negative s tau times the Laplace transform of g t plus tau. Alright, I hope this video helped.